There's two ways that you can deal with this. If you have a number over a variable, the easiest thing to do is to move that expression up into the numerator. So for example, like if it's 1 over x to the third, you don't do the quotient rule there. You bring the x to the third up. So here, when you see that you have a number over this variable expression, what I personally would do is I would move this up into the numerator. And when you do that, it becomes a negative exponent. And then once you have that, you see the structure of parentheses to a number. So anytime we have parentheses to a number, that's our general power rule. Now, do keep in mind, it's not like this is the only way to deal with this. You could, if you wanted to, instead of doing this, bring the exponent up, you could go through the quotient rule, but it's going to be significantly more simplification. Okay, so I'm going to bring this up, I'm going to rewrite it, and now I'm going to take my derivative, and I'm going to use the general power rule to take the derivative. So I'm going to bring down the exponent just like I always would, and I'm going to multiply 5 times negative 10. So that gives us negative 50. Then just like if I have x squared, I bring down the 2, I keep it as x. I'm going to keep the base as 4x minus 1, and then subtract 1 from the exponent to get negative 11. Now, that would be my quote-unquote derivative of the outer. I then have to multiply by the derivative of the inner, and the inner is this quantity in parentheses. So I multiply by the derivative of 4x, which is just 4, and the derivative of negative 1, which would go to 0. So again, what will happen here is this is the derivative of the outer times the derivative of the inner. Now, for the general power rule, usually what will happen is something in front of the parentheses and at the end of the parentheses will combine. So this negative 50 and 4, I can of course multiply together and get negative 200, and then the 4x minus 1 to the negative 11 stays. And this would be my derivative.